Hey, hello students. This is the video I'm making for Algebra 2, Unit 4, Lesson 6. And the lesson is about writing equation for exponential functions. So what is the learning target is I can write equation of functions, exponential function from input-output pairs, that means x and y, even when the input pairs are not one unit apart. It means it doesn't have to be x increases by 1, 1, 1, 1, but it could be also increasing by half, or it could be 1/4, and likewise. So let's go directly to practice problem. So I'm going to work on the practice problem. So the first problem is here. So this is students practice problem. This is the first one. Uh, so here the question is asked, a population, let me use the marker. Yeah. So population of 1,500 insect grows exponentially by 3 every week. Select all that represents population P, a function of time T. So the input output is given. Since the population was 1,500. So what I would do is, even though we don't need this, I will make this table just to get an idea that so it is T and this is P population when years, how many years from the time 1500. So in the beginning, 0, it was 1500. And then in 1 week, so that means let's see, this is 1. So T is 1 week. From here to here is 1 week. So the grows by 3%, grows by a factor 3. So the B here is 3. So you're going to multiply 3. So naturally, this is becoming 4,500. So our goal is to know whether which among this is correct, right? So what do we need to know is what is, so everywhere you can see clearly the first part is A, that means that's A 100%. In the beginning it was, so the first one is, this is A, right? The question, what is B? And the B is 3, this is for week. So the question is asking, select all equation that represent the population P of a function at a time in T days. So that means it doesn't say week, so it says days. So this is days, okay? So I'm gonna change this. Let me take off this. So and then yeah. So this is we want it's like days 0 to 1 and 2 and 3 and 4 and 5 and 6 and 7. So what they gave us, this was 3. So this was 3. B is 3. E is for every week. That means from here to here is every week, right? So we want to know every day here. That's the one I'm talking. So this one, the B is given to you, but we want every day. So if it is every day, let's call it uppercase B. So in the function, we can call y equals a times, originally it was b raised to x, right? But now that b will change to, so this b which you talk about is, because how many days are there in a week? So you see, how many times do you multiply this? Uppercase b is 1, 2, oh God. So we need to know every day. Let me do it one more time. So from here to here, what is that b? Uppercase, I'll use the uppercase b. So every day will be like once, twice, thrice, 4, 5, 6, and 7. So you have 7 b's, right? So b raised to 7 equals this 3, because you're multiplying 7 times. So this is 3. So this b becomes 3 raised to 1, 7. So that's the uh, growth factor for every day. So the equation, the one that the formula is a raised to b raised to x, but now because it is every day, it becomes y. The first one is uh, 1500 multiplied by, so this b was for a week, but we want every day, right? So this is the one that we have to use, this b, which is 3 raised to 1 7, and then the days, t. So I put t, you can write t here. And remember, this is same as writing 3 raised to 1 7 times t, which is 3 raised to t over 7. So the answer that you got correct are, if you look at the B part, see this part? This is the same thing that I showed that side, and also this one, D part, which is right here. So two answers, this one, and I hope that takes care. Let's go to the next one. Okay, the next second question is a tuition fee at the public universities. This is in the year 2008. And from 2008, there are 2 years, so it increases by not 1 but 2 years. It increased by percent increase 15%. So 15% is 0.15. So the B that is going to be here is for B for 2 years will be 0.15. Now this is, let me draw the thing also, that means here. Uh, so what this means is, in the beginning, it was 21,000 here, then it is 1, 2, 3, and so on. Okay, so we can use y, so they use input as the y, and f of y is the output. I don't know why they give y, that's stupid, they should have given x. Anyways, now in 2 years, it means from here to here, they gave you, because from 2000, this is 2008, this is 2009, this is 2010. So in 2 years, it grows by 15%. So your B becomes, I'm sorry, here, this will be 1 plus the percent increase, which is 1 plus 0.15, and that will be 1.15. So this B, which is right here, will be 1.15. So, so let's see what is going to be right here. So the main thing is, if it is f of y, so the formula is f of y. Every 2 years it says. So from here to, if you use every 2 years, this is the growth factor. But because in 2 years there should be another factor multiplied twice, and that is the important number, that let's call it b and b. And because there are two like this, so that b will be the original 1.15, 1.15 raised to the years. So it's going to be 1 divided by 2, because of there are 2 years, and raised to y. So which could be written as 1 point, so the 15,000, which was, sorry, this 21,000 will be right here. Let me clean this. So this will be, in the beginning, the fee was 21,000, and every year will be 1.15 raised to y divided by 2. So let's see which is the correct answer here. So first question, the tuition fee cost can be defined by, yeah, absolutely correct, and that's what we did right here, right? So that's correct. The tuition fee cost increased by 7.5, and here the tuition fee increased by 7.2%. So what we have to do is, we have to figure out what is this thing, or this part. See, this is what factor, what is that thing is. So if you use your calculator, this is the factor every year. So when you work this out and do on the calculator, you end up getting 1.0723. What that means is, it means 1 plus 0.723, and that is nothing but, this is 100%, the original one, plus you multiply 100 up and 100 down, so that will give you 72.3 divided by 100, and this whole thing is 7.23%. So every year the percent increases 7.23, and you go back and you can see 7 point, this is not correct, but this is the approximate because 7.23 is same as 7 point. So this is wrong, this is correct. The tuition fee cost roughly doubles. So what does that mean? We have to use 10. In the beginning, it was 21,000. Does it become 42,000 in 10 years? So what you have to do is plug in y equals 10 in the formula. The formula is right here. So you put f of 10 and see what happens is 21,000 multiplied by 1.15 raised to this input will be 10, 10 divided by 2, and use the calculator, which is 21,000 times 1.15 raised to 10, sorry, 5, because 10 divided by 2 is that. And if you calculate this, you end up getting the answer as, so this answer you put on the calculator, you get 42,238.5, which is almost double, right? So that's the last part is a tuition fee cost can be approximated by this, which represents decades from since 2008. And that also is correct. If you see the thing I showed is here, I can go on doing this and until, let me take this off everything. So if you want to do a decade, so the original is, this is the original and we go all the way, okay, and and 10 years, that's one decade. So from 0 to 1 is a decade, and you can, if D stands for that, and then you can use the formula as the same thing, this one, but it will be f of D every 10 years, it is 21,000 times 1.15 raised to, uh, so we are not going to use 1.15, that is for every year, right? So let me take this off, but we have seen that it doubles every 10 years. So we still remember, this is, in the beginning it was 21,000 in 2008, and after in 2000 maybe 18, after 10 years, it's like this is just approximately. When you say approximately, it doubles. Now when you talk about doubles, that's like 2. So the b the b will be 2, so it is 2 raised to d. So that's the modeling of every 10 years. So hope that helps. Let's go to the next. So in the classroom, I did do a similar problem. This one, I look at this question here, they give you some information. Now remember, uh, for every increase in the input of 1, that means x increases from 0 to 1, we don't have no information here, right? So we don't know anything here. So the goal is when you put this one, gx, this is the starting number that is already a. So we already know this is a. But this is what, when we want to write what is that b, is it is the growth factor. So this growth factor is, of course, in this case, it is decay with the graph is decreasing. So you can say this is a decay factor. So I can take this off and write decay factor. So now we need to know, first of all, mm, the information that is provided to us is, you can see from here 1, 2, and 3. There are 3 halves. So this is like half. This is one half. So there are, so for every 3 parts increase, I'm not saying every one increases. I'm saying three. So for every 3 halves, so I will say 3 halves. So for every 3 halves increase, we want to know what is the growth factor, the decay factor. So what we do is, in this case, first let's only find out what is the decay factor from the 0 all the way here. Okay, so they gave you, this is the output when it is 1/3. So this is when it is in the beginning. So you want to find from all the way here. So we will have to divide. So if I have this, let's say 0, so this is like half, this is like 1 half, and then there is 2, and so on. So what did they give us is 10 is the original one. Okay, so this is, let's see, x, and that is f of x. From So for the increasing from 0 to 1, for this one there are three halves. As I was saying, there are three halves, and the number goes from here and becomes 1.2 1.25. So what is the factor from? So for that, so that is b. So I'm not talking. This is not this b. Don't get confused. This b which we are using in the formula, this b is for every uh, increase in x by 1. Okay, but then we have fractions here, right? So we have input fractions. So what you have to do is we'll try to uh, we'll use let's call this as b uppercase, because for this one we'll say there are three halves, right? So for this let's divide 1.5. So the b for three halves. So this b I'm using decay factor for three. So 1.25 is when it is 1.5 input, and in the beginning it was 10, and you see it becomes 0.125. So that means, so so this is the b. But then we want to know, or we need to know from 0 to 1. So that's what we want, right? So instead of doing this, first I'll go for every half, how much is this, right? And because there are three halves, so for every one half will be raised to one third. So this is like for every three halves. So for every one half, the decay factor will be 0.125 raised to one third. So the reason is 0.125 one third multiply 0.125 one third multiply 0.125 one third will give you 0.125, and that's what the decay factor was from 0 to this. See? So which was 0 0.125. But the lowercase b, so this is every half, right? But we want twice. So if you want twice, I'll use the blue color. We want 1 and 2, because for every one. So the b stands for every one. So that's it. So I'm gonna write down the b from in the formula is twice. So whatever we got here is multiplied twice, because it is 1 and 2. See, twice. So this part is multiplied twice. So the answer becomes 0.125 raised to 2/3. This part. So this is the decay factor for every increase of x. So this is for when x increases by 0, 1, 2, 3. That's what you do. And this one is for every three halves, and this one is for every one half. It's so much confusion here. So if they have given you for every one half, you first find a factor here, then go for a lowest interval, that is 0 to 1, and then you see for 1 how many are there. So you get 1 and 2, and that's why you have 2/3. So this two third is because it is twice 2/3. So kind of confusing, but the lesson is about, if they have not given you uh, every interval of 1, but fractional from, let's say, from 0 to give you when the input was 1.5, what happens. So that's how it is. So hope this helps. So this is the b. So finally they had asked us what is value and show your reasoning, and we showed the reasoning. So the b is 0.1, what is that, I forgot, 125, yeah, raised to 2/3. And thank let's go to the last one, last two. So this question is about if you can stop for a while and read. The number of fish in the lake is growing exponentially. The table shows in thousand. So whatever the numbers are given is thousand. So the question number 4 is about, I think this is from lesson 3 if you missed anything earlier. So this one, a number of fish in the lake is growing exponentially and it's given in thousands. So this, even though there is a 10, it's 10,000. And since it was first measured, so in the beginning, this is the start. So this is like A, this is the A, the beginning. By what factor does the population grow every 2 years? So here the input increases by 2, so this is plus 2. So what factor is this? So we can easily divide 40, divide by 10, and we get 4. We can clearly see 4, that means it is 4 times, and it's like it quadruples every 2 years. So by what factor does the population grow every, oh, you're asking every 2 years, so it's like 4 times. 4 is a factor. Use this information to fill the 4 years and 6 years. So we can clearly see. So it means this B is 4 times for every 2 years. So but we have to fill this, right? So to fill this every 4 years. So if this is 40, this will be another 2 years. If you add plus 2, this is going to be 80. And if this is 5 and the next one is 6, so from here to here is plus 2, and this will go to 160, correct? So every 2 years, that's how it is. And one more thing I want you to observe, this is for every 2 years, right? So this is 4 times. That means we want to know every year what is that multiplies, uh, like from here to here, and then again from here to here, right? So two, we need to know what number is this that multiplies. Of course, we know common sense it is 4, so the only way is it is 2 times 2. But what if so it's like 2 and 2, right? So every time you just multiply every year, so the second question, by what factor does the population grow every year? The answer is clearly 2. So we can say, okay, 2 times 2 is, this will be 20, then again 20 times this multiplied by 2 will be, so this 40 will be double of 80, right? So we already know the answer. By what factor does the population grow every year? That's the one. So in this case, the quadruples every 2 years, but every year it doubles. So that's what I mean. In other words, one of them, this one is, remember, because it's like increasing 2 years. So if you want to know only 1 year, the right way to do is if whatever is given is, let's say, B is whatever is for 2 years is 2. But if you want to know for every year, then it becomes the same B raised to 1 divided by how many small b's, like how many b's, this is small b lowercase, this is lowercase, so two of them, so that's why it will become like this way. So the b becomes 2 raised to half. Sorry, the original was 4, right? For every 2 years it was 4, correct? So I have to put uh, so this is 4, that is for 2 years, for 2 years, but now it becomes 4 raised to 1 divided by 2. Of course, we know that this is a square root of 4 and that is 2. So this is like a common sense, but my question is, what if it was, instead of 4, if this number was 5? Then the common sense fails like this, right? So you have to write, if it was 5, if this was 5, your b will be 5 raised to 1 over 2. So if I want to model this into a function, let's say f of x becomes equal, in the beginning it was 10 times the b, this is the b, pi raised to 1 half, and then put x in it, which eventually will become f of x equals 10 times y raised to x over 2. And we are done. So this formula works for every increase in x by 1. So x increases by 1. So in case if you missed unit for lesson 3, you got confused. These are like little practice problem. Again, they repeat. Every value of the home increases by every year. That means x increases from 0 to 1. So and by how much? 7%. Now what is 7%? Is 7 divided by 100, which is 0.07. That means the growth factor becomes 1 plus the percent increase, which is 1 plus this number 0.07 is 1.07. And then the question is it doubles every decade. So decade means 10 years. So what do we do here is multiply b 1.07. So this we are going to multiply by uh, 10 years. So 10 times 10. If you use a calculator, you get 1.97. So each decade, the value of the home increases by almost a factor of 2. So this is almost like a factor of 2, like 100%. So that's what, so this means it doubles. That's why I say doubles means twice. So I hope that takes care of that. Yeah, so with this, there were problem number 1, 2, 3, 4, 5, practice problem for unit 4. Lesson number 6. So hope that helps. So whatever the learning target was, if x did not increase by every each, so if x did not increase by 1 but increase by fraction, let's say instead of x going from 0, 1, 2, 3, no, it could go from 0 to half to 1 and 1 half, like that. Or you can go 0, 1/4, half, 1 and 1, sorry, 3/4. So such cases you have to be very careful to figure out what is the data for every small increase of x, and then check on how many of those small ones make it. So how many x uh, from goes from 0 to 1. So either they may give you somewhere here or maybe in between. So you have to be very careful. That's, so hope this works. Write down all the uh, every step in your problem and make sure uh, turn it in your packet, and also make sure what in your comments in the YouTube link that I have, you could put a little comment there saying what is that one thing you will learn from this video. Would appreciate that so much. Thank you so much, and very soon I will be doing video for practice problem lesson 7. So hope that helps.